Hey y'all, this is Miss Morrison, Sarah, and this is Properties of Logarithms. And the way I think about properties of logarithms, I kind of use the common words of maybe combining like terms. So these properties of logarithms are basically how to combine like terms or to expand terms. For example, like back in the day, 2x plus 3x plus 6x is what? It's 11x? Yeah, like that's how we combined like terms in algebra. We just added the big fat numbers in front. But then when we have logs, say log 2x plus log 3x plus log 6x, this is not going to add up to some kind of 11x because there are totally different rules for how to combine like terms. So this is not going to be equal to like log whatever 11x, or even if you think it's 3 log x, whatever, it's not that. So how we combine like terms with logarithms is different from how we combine like terms in algebra, and it's different because it's the inverse of how we combine like terms with exponentials. So as we're doing 3.4, or these properties of logarithms, if you want to look back into your Blackboard, to the handouts, I've shown you this before in a different video, but look in your handouts, and there should be some old college algebra handouts. And that's where we're going to find this hoopla about the properties of logarithms. And I want to show you this handout before we get on the worksheet. Okay, so what I'm about to show you in this handout is everything at the top of this worksheet. Okay, so back in the day, if you remember, for exponentials, there was a rule called the product rule, where if you're multiplying like bases, you add the exponents. For example, hold on, let me find a blank page. Okay, so this was for exponentials. Let's say we have x squared times x to the 5th. For exponentials, you add the exponents to get x to the 7. You see that? Okay. But when we have logarithms, if you start with multiplication, just like on exponentials, if we start with multiplication, the logs get added. You split them up into 2 different pieces. So when we multiply exponentials, they get smaller, or the terms, it looks like it gets smaller, but the exponent gets bigger, but there's less things in our answer. Whereas when you multiply logarithms like this sucker, or if there's something inside the parentheses that are multiplied, they separate with a plus. Okay, or if we look at this quotient rule, it says if you have 2 somethings being divided, let's say x to the 5th over x squared, the math that you do to divide those is you subtract the exponents and you get x to the 3rd. Okay, well, for logarithms, if they are being divided, we don't actually subtract in the exponents, we subtract logs. So if I would have, let's say, log x to the 5 over x to the 2, it does not become log x to the 3 like exponents do. Instead, it separates into 2 logs of x to the 5 minus log x to the 2. And the way you can remember that minus is because when we're dealing with regular old exponentials, we subtract to get this 3. So for logs, we don't actually subtract the exponential, we subtract the whole term, log of x to the 5 minus log of x to the 2. It's kind of like distributing. So exponential rules and logarithm rules are inverses of each other, meaning you can group them the same way in your head. Okay, so let's look at this paper. It says something called the product property turns something all squished together, and those could be squished together with a pretend multiply. It turns multiply into addition. So when we have a log with things being multiplied inside of it, the math that we're going to have to do from now on is we split it using pluses. And then there's way more math that we're going to learn. But right now, this is just how to expand and condense logs so that we can do the fancy math to solve big word problems. Okay, so let's look at this log. We have log. And then I have a bunch of stuff being multiplied inside here. It's kind of like 2 multiply x multiply y. See that? Yeah. With the log in front. Yeah. Okay, and it says use the property of logarithms to write the logarithms as a sum. So sometimes in the future, we're going to need to write things as a bunch of little chunks being added together, or the sum. So that's why we're practicing. Then it says, then simplify if possible. Okay, so if we have multiply, oops, that was dumb. If we have multiply, it goes to plus. So let's go. I'm going to have you start off with a log, and then you read it left to right. So the first thing I see on my left is a 2, so I'm going to write a 2. Then that multiply dot goes to a plus sign. Then you keep going, log x. It's kind of like you distribute that log to everything in the parentheses, but the multiply goes to a plus. Okay. And then distribute that log to the y, so log y, but the multiply goes to a plus. And hey, we just expanded this, or we wrote this log as a sum. And the last thing it says simplify. Simplify means, let's say I had log of 100, and there's a pretend 10 down there. And then we change that 100 to 10 squared. And then we use that cool trick from the last section where the log 10 cancels and you just get a 2. Yeah. Or simplify means use the log button in your calculator, or you might have to press that. Whoa, that says math. Ooh. Math, and then down to log base. Or you might have to press that LN button on your calculator. So either you do it this brain way or the calculator way. To simplify. But either way, to simplify, you have to have the same basement number as you do this big fat number, 10. They have to be the same to simplify. Well, let's look at us. All of these suckers have pretend little 10s down there. And you do not have to type the tiny 10s into your homework. If you want to, it should count it correct. But if I put those tiny 10s down there, I don't see anywhere I can simplify any double 10s. You see? I don't see any 10, 10, 10, 10, 10, 10. So I cannot simplify that. Okay, let's go to number 2. It looks kind of the same, only now it has a subscript. So we're still going to say log big fat 2 plus log big fat X plus log big fat Y. And you're wondering, where did she get that from? It's the same as number 1, guys. It's the same as number 1. Look at it. It's the exact same thing. Only there's a tiny little 2 down there. So we're going to put a tiny little 2 in the basement. Okay, and then now let's see if we can use that trick of simplifying. Well, if I have log 2, that can cancel to whatever the exponent is. So what's our exponent of this big fat 2? Like this big fat 2 right here. It's a 1. So if I cancel the log 2, it just gives me the exponent of 1. So that's what the simplify word means. It means if you have a basement or a subscript and a big old fat number that are the same, you can probably do some canceling. So this will cancel to the exponent of 1 and then plus log 2x, and you have to type these 2's into your homework. So on the problems with a pretend 10, you don't have to type that 10 into your homework. But the 2's, you for sure do. Okay, let's look at this sucker. Number 3, it says ln, and then it says 3 times a plus b. Okay, what in the world? Okay, well, so far we're just talking about that product rule, because it says use the product. Okay, so let's see, what is producting here? I don't see any pretend little multiply dots, but I do see some big boy multiply, parentheses. Look at that, 3 times big fat a plus b. So those are the 2 things that we need to separate onto an ln. So just like on number 2, we had 2xy. They were all separated with multiply dots. So that's 3 things. So I wrote down 3 things in my answer. Okay, here, the only things that are multiplying are the 3 and the a plus b. That's 2 things. The b don't count because it don't have a little dot before it. It's got a plus sign before it. All right, so we're going to have an ln 3, and then we're going to have a ln. I'm going to go ahead and put that a plus b in parentheses because it scares me. And then that dot goes to a plus sign. Yeah. And then let's remember how to simplify ln's. The only way we can simplify ln's is if there's like an e in it already, because then you put a pretend little e down there. And then the ln cancels, and you just get the exponent 3. But that's only if there's already a big fat E written. We don't have a big fat E written, so I cannot simplify this one. So this is done. And if you want to, you can put the tiny little e in your homework, but it won't count it wrong because it's pretend. It's like understood, it's imaginary. And then in your homework, it might not say capital LN, it might say LN, like lowercase l. Okay. So that's the product property where multiply goes to plus. Now let's go to the quotient property. Quotient property we already talked about. It's where you subtract. If you start with division, you go to subtraction. So the quotient property up here says, hey guys, see this division? Yeah, we're going to split up this log using subtraction. Okay, and then the log in the little subscript kind of gets distributized to everything in the parentheses. Okay, so let's go. Let's look at number 4. First, what's being divided? The z and the 49. So we're going to have this log 7 on a z and a 49. And you always write the top minus the bottom. Oops. The bottom. Just like when we have these when we say x to the 5th over x to the 2, to get the 3, we say the top minus the bottom. 5 minus 2. Yeah. Okay, so that's why we have to write the top letter first, Z. So we're going to have log baby 7, Z. Then I'll log baby 7, 49. And that division goes to a big fat subtraction. Hey! Okay, now let's see if we can do that whole simplifying witchcraft. Remember where the subscript number is the same as the big fat number? Okay, yeah, let's go. So I see a subscript of a 7, and I think I can scratch that out and put 7 squared. Woohoo! So this first one says log 7z, and they all have crosses through them, minus log 7, and then we scratched out the 49, and we put 7 squared. Okay, now the only one that's going to simplify is the one with the basement and the big fat number the same. So that's just this guy, the second one. So this is all going to cancel that. And all we're going to write is a big fat 2. So our final answer is log 7, Z, minus big fat 2. And everything is big and normal. The only thing that's tiny and small is that 7, and it's in the subscript. It's in the basement. All right, let's go to number 5. All right, we're going to start by saying log 7, and then you do the top guy, A, minus the bottom guy, log 714. And you always have to put that log on everything you write. Remember, it's kind of like distributing. Don't ever tell that to another person. Okay. Anyway, so this log 7a will stay the same. It can't do anything. Okay. But then this 14, we can write it as we can either stop here, or we can try and go another extra step. If I wanted to try another extra step, I could change this 14 to not 7 squared, but maybe 7 times 2. Yeah. And then we could use the product rule. And remember, the product rule says, let's slide up here. If you have stuff that's multiplying, it changes. The multiply goes to plus. Multiply goes to plus. So let's try this sucker. We're going to have log 7a. That's the same. Where the only thing small is that 7, and it's the subscript, minus a bunch of stuff in here. Let's see what happens in here. I'm going to have log 7. And then this multiply sign goes to plus, and I have log 2. Okay, now remembering the simplifying rules, that subscript in the big number and the log can cancel out if you have an exponent. Well, let's look. What's the exponent of this log 7? 1. So all that's going to cancel out. So we're going to have log 7a minus, I put some brackets, and that log 7 goes to a 1. And then that log 2, he does nothing. He just sits there because